Thank you so much, Dan. First of all, you giving us a time. You give us a brief about both of us. So we are construction management students in ASU, and we are currently enrolled to information technology course. In that, we were doing a research on autonomous construction vehicles. So this call is to understand more about autonomous construction vehicles and how it will be impact on industry. Before beginning, we want you to give a small brief to our viewers. So this video is going to present in the our university. So yeah, to get to know you more.
Sure. Yeah. My name is Ryan Johanson. I work for Whiting Turner Contracting Company. I'm a project manager. I've been with Whiting Turner for about 7 years. Worked on 4 or 5 projects now, anywhere from a couple $1 million up to about $150 million project size. So
Hmm. Honestly speaking, we know you, Ran, because we saw you many times in the career fair. So yeah,
that's right. Yeah.
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 Okay, okay. So generally, this flow of this interview is like first few questions was about like how what challenges that ACV gonna solve, or autonomous construction vehicles gonna solve. Then what is the practices? What is kind of a practice is ACV in the current stage, and then what is the future.
Sure.
So we have a group of questions, and we can wrap up in 50 to 20 minutes.
Yeah.
So yeah, so let me start with the first question. Like, what do you think? Like, what gonna be challenges in there in the current construction state, which we can solve with the autonomous construction vehicles?
I think a big way to incorporate autonomous construction vehicles is, at least first and foremost, I think, is getting into a lot of like MEP layout. So specifically when it comes to podium style buildings, anything over concrete, it's be a great QC tool if it was synced up with the plans or the survey network, so to speak, and could drive around and verify that what is laid out is in the correct
Okay.
location prior to
Mm-hmm.
starting
Mm-hmm.
framing, things like that. That's one option.
Okay.
Um, Others I've seen that I think are pretty impressive that could be good options are, labor. Obviously, skilled labor is a huge
Mm-hmm.
issue in the
Right.
industry,
Correct.
and it's not gonna, can't replace necessarily electrician at the
Mm.
time. But what it could help
Right.
with
Mm.
is, in large areas,
Mm.
large, very flat areas, specifically in a lot of the buildings that we do, like tilt up concrete.
Mm-hmm.
You could use an autonomous vehicle with sensing to actually paint those walls or
Okay.
coat those walls. You could do something along the lines of fireproofing if there's exposed steel that it could detect and coat
Mm-hmm.
with fire intumescent paint. Things like that I think are good applications for ACVs.
Okay, labor shortage and MEV outlets. Okay,
Yeah.
thank you so much, Ran. With this, I have a like second questions follow with this. Like, what main significant value if I wanted to implement kind of my vehicles replaced with autonomous vehicles? What are the significant value it will gonna import in the project?
I think the biggest value is, one, it's something that is extremely reliable. Generally speaking, you don't have to worry about trying to find labor to get out there and get
Mm-hmm.
that thing done.
Mm.
Scheduling would be a huge aspect of it because it would
Okay.
be readily
Mm-hmm.
available and
Mm-hmm.
deployable when you're ready for it, rather than trying to schedule ahead of time and working around other projects, whatever it may be.
Mm-hmm.
The usual challenges of the industry. So I would think efficiency is the big one when it comes to scheduling, and then
Okay.
also the accuracy.
Okay. Okay.
There's less human error. So
Mm-hmm. Okay. Okay. As far as I understand about Whiting Turner, the Whiting Turner is known about this like safety. They are very strict about safety. They are very concerned about safety. This
mhm.
my third question is like if I adopt like if I my if I implement my ACVs in the construction projects, what they gonna improve in terms of safety, and what gonna be the impact on the safety, and what your take of this?
Hmm. That would be cool. I didn't think about it from a safety perspective, but at the same time, anything that an ACV is doing, is obviously it's a lot less, concerning if an ACV were to, have, cause a, I guess if, for example, if it's driving along an elevated deck
Mhm.
and there's no human involved in that, there's a lot less of a fall
Ah,
risk for somebody who'd be up there if
right.
that was replaced by an ACV.
Correct.
Same goes for painting the side of a wall or coating
Mhm.
something. You're by minimizing the human exposure. and
Mm-hmm.
using ACVs, I would think that'd be a huge value.
Okay.
Just might damage some
Right.
robots, but
Right. Yeah. Correct. Cost is it the always be a great like very important factor when is a big project is concerned. Like, what do you think to implement ACV is gonna impact economically and like on the impact on profitability or of the project and all?
yeah, it becomes kind of an investment, I would imagine, because it probably would be upfront costs for future payoff kind of thing, assuming that it can continue to work for X amount of years. Um, but I think a big part of that is, for the far-reaching effects is as we currently have the labor shortage with skilled labor,
Mm-hmm.
the more that we can replace with an autonomous vehicle only helps to improve and remediate that labor shortage that we have. Obviously we still need workers and human beings for a lot of the work that we do, but
Mm-hmm.
anything that we can do to free up other people in skilled labor areas by using ACV seems like a good option to help you know
Okay.
minimize that bottleneck.
Mm-hmm. Okay. Um my last question for this challenges category is, um, there are like we always see that construction projects gone through the delays, like we have a resources problem and all those delays happens with the various reasons. What do you think if we implement this ACVs in the project, so it's gonna reduce our delays in the project?
So sorry, you're saying as far as timelines, or sorry, explain that
Yeah,
question again. Yeah.
yeah, about timelines, yeah, delays basically, to solve
Yeah.
delays. Yeah. Yeah.
Oh yeah, I would think. I mean, I haven't specifically used an ACV myself, but I would imagine that if we did have one, again, the availability aspect of it and the ability to kind of deploy it
Mm-hmm.
at our will, so to speak, would allow us significant improvements in scheduling and efficiency on site, because essentially we don't have to worry about mobilizing a crew, finding people to staff that crew, whatever that may be. So
Okay.
yeah.
Okay. uh Thank you, Ren. Uh, like I've as you said, you have not witnessed any construction autonomous construction vehicles in your career and all those things.
Mhm.
So I wanted to know ki if you wanted to like import that, so is there any specific type of training and all those things you have known about and that is required and all those things? Do you have any idea about that?
I don't have a ton. We've talked with a couple companies that offer ACV services, like I mentioned, for kind of some of the larger jobs like painting, large, wide tilt up walls, things like that.
Mm-hmm.
And then also for deck scanning, as I mentioned, I've talked to
Correct.
companies involving that,
Hmm.
but I haven't had any, taken a class or learned more about it. That would be
Okay.
something that, yeah, would be
Okay.
nice to
Makes sense.
hear about.
Makes sense.
Yeah.
Okay, thank you, Ryan. Let's move to our last category. I just
Mhm.
wanted to know, ki like does the in the right now in this stage, does we need ACVs to improve our projects? And if it is yes, then what is the future of next 5 years or 10 years of the ACVs? What do you think?
I would say, yeah, absolutely. I mean, everything's going more autonomous, just throughout industry in general.
Mm-hmm.
And I think as that technology develops, and as we are able to, I mean, we see it in the medical field quite a bit now, where they even have autonomous surgeries and things like that. That's such a high level of precision that
Mm-hmm.
even in construction, we don't need that kind of precision. We can get
Okay.
by with significantly less. So I'd
Mm-hmm.
imagine down the road, I could see, robots going up and down, or autonomous vehicles going up and down corridors, installing insulation, possibly even putting up drywall. I mean, all it would take is an advanced LiDAR scanning in some kind of way to identify what's around them and install, and somebody back checking QCing on the back end just to make sure nothing's going crazy. But I could see, in the next 10 years,
Mm-hmm.
maybe 20 to 30% of the workforce starting to be replaced by this kind of thing in specific industries, who knows, or within specific trades. So,
Uh,
um, but yeah,
Interesting. Yeah. And like if we wanted to go for a sustainable development, does ACV will be a good option?
I would think so. I mean, to me, yeah, the flexibility of being able to deploy it whenever you need it, kind of thing, and then
Mm,
also having a control over how, the precision with which things get installed is,
mhm,
that's the hardest part, is the human element, right? So,
mhm,
minimizing that human error and human element is only going to help. make these projects go faster and higher quality. So.
Yeah. Okay. Thank you so much, Ran. We have sum up with our questions. We had a great time. We have learned a lot of things about you and a lot of things we have discussed today. Thank you so much for your time and happy Thanksgiving to you. Yeah.
No
Thank you
problem,
so
guys. Happy
much,
Thanksgiving to you
Ryan.
too.
Yeah.
Yeah,
Thank you.
thank
Have
you.
a good one.
See you
Yeah.
guys.
First of all, thank you so much, Victor. You have given us some time. Yeah, this
No
is
problem.
amazing opportunity for us to talk to you. Uh, I'll give you a brief introduction of both of us. So my name is Dev, and she's my project partner Vibhuti. We are currently doing masters in construction management, and we have enrolled in the course called Information Technology in Construction. In that, we are doing this project on the autonomous construction vehicles. So for that project, we are talking with the industry professionals to get more information about how this tech works, how this techs implement in the construction industry. So that this is a part of our project. So thank you so much for your time. So we have a very short 30 minutes of time. In that, the flow is like we wanted to understand like how this industry cater, which kind of problem this technology caters in the industry, then how this technology uses in the practice, and finally how is the future and how is the future direction for this industry. So that things I wanted to understand from you and all this.
Absolutely. Okay.
Yeah, before the beginning, let us know about your like how's your career path and how's your interest and how you went into this sector and all this thing.
Absolutely.
Yeah.
I did an undergrad in engineering physics, and I have a grad in vehicle engineering, mostly focused on system development for
Okay.
vehicle and machinery, more or less.
Uh-huh.
I've been working 6 years at Volvo Autonomous Solutions. It's a subsidiary company in the Volvo Group. So it's the same Volvo as trucks and buses, but it's different Volvo cars. But so working essentially with automation systems for trucks and construction machinery. And when we say construction machinery, we mean mostly haulers and to some extent wheel loaders. And then my focus is entirely towards quarry and mining. So I can talk for hours probably about quarry and mining, but I don't have any knowledge about building sites or anything like that.
Okay. Okay.
So
okay. Fine.
Yeah,
Thank you.
that's my background. Thanks.
Yeah, that's gonna be a very, very interesting profile. So we are excited to discuss few of the questions, and I wanted to know your perspective on this tech. So we'll start. My first question I wanted to know, what do you think about like if we use this autonomous construction vehicles in the construction industry? What do you think? What kind of a problem this tech gonna solve in this construction field or something like that?
So there's several different problems in the construction field to solve, obviously, with self-driving. Self-driving, I would also add remote operated here, because it's quite an important thing also, like remote operated and self-driving construction machinery. And especially with regards to quarry and mining. I mean, if you think about hauling, for example, at least in Europe and the US, you have a huge shortage of drivers, both in the transport industry, but also in the like quarry and mining industry. It's really difficult to find drivers. So that shortage is going to be heavily alleviated by using self-driving haulers, self-driving trucks in quarries and mines. And it's quite obviously it's the easiest thing to automate, because essentially if you have a quarry, it's essentially like it's a train track more or less, but there's no track. I mean, there's no rails there, but it's driving back and forth, back and forth, back and forth all over it. And also another important thing is it's a confined area.
Okay.
I mean, from a safety standpoint, automating it is really the lowest hanging fruit, because the work you're trying to automate is very easily described for a computer. And you don't have to worry about being able to differentiate between a cat and drive over the cat or don't drive over the school child. This is the problem you have if you look at like self-driving, like robotaxis, for example. There's a huge problem for robotaxis, actually. Like being able to don't emergency brake for a cat, but do emergency brake for the kid running over the street. There's no kids in the quarry. In fact, you can easily confine it so there's no people whatsoever in the quarry besides like one guy operating a excavator. So from that standpoint, it's very easy to automate it, and you really solve the shortage of drivers. Essentially, what you have, if you have a medium-sized quarry, you probably have like 4 or 5 drivers driving around big cat trucks right now, like 100-ton trucks. And you can easily replace that with like one guy automating a fleet of these trucks instead, if you automate them. So then you have like reduced your like hauling workforce by 80%, essentially. And of course, like the bigger the site you have, the more efficiency you're going to gain, because you're like unlikely to more. I mean, we've seen sites with up to 20 agents on it, and it's still fully manageable by a single person. Essentially sitting in front of a control board with a with interface showing, okay, this is where your machines are currently driving. Simple inputs like the actions you would have to take, because I know one of your questions was like, what kind of training would you need? So the input you need to have basically as an operator for this, you don't need to drive a hauler. You don't need to understand, like you don't need to have a driver license for a hauler or anything like that, or for a truck. What you do need to understand is like, it's more like, it's probably good if you take like a 20-year-old kid with like experience in video games or something like that, because that's more like it. You have a user interface, and occasionally you're gonna get a pop-up saying, okay, yeah, there's something on the road ahead of me. Can you please verify what it is? Okay, yes, you can. Okay, that was machine number 21. It says it has an obstacle in the road ahead of it. Okay, yeah, click machine 21. Let's open up the camera, see what's there. Okay, is it a rock? No, it was not a rock. It looks more like it was just some leaves blowing in the wind or something like that. That was mislabeled. Okay, you can proceed. Safe to proceed. Go. This is the kind of input that operator needs to give, and this kind of knowledge that operator needs to learn and understand. It's very simple, especially if you have like young people who are like well versed with video games and computer systems in general. And there's generally it's very easy to find these kids. So it's a huge problem that you're essentially replacing like hard to find drivers with easy to find like youngsters well versed in like video gaming and computers, etc.
Yeah. So it's like the whole opposite to the traditional approach to this like tech vehicles. When this technology comes into the picture, there is always the concern with the safety. What your take on, like, if you use this autonomous construction vehicles, does this ACVs contribute in the safety on the construction site? Like, what about your take on the safety if you use these vehicles on the site?
I mean, obviously, like a big problem with self-driving equipment is the fact that they're not necessarily safe. I mean, even if you're trying to have like very good written software, but also testing, etc., you're still always going to have a residual risk that it will not be able to label. If a person accidentally walks into the construction site, it's not going to be able to properly label the person as an obstacle to avoid or stop for in time, and then you might have a collision. You also have, of course, a risk that if you have you are probably going to need to have some other machinery besides trucks and haulers, like an excavator or wheel loader, will be operated by a person. And of course, the risk is that, okay, can it like one of these trucks or haulers accidentally drive into the excavator or the wheel loader? And in that case, how dangerous will it be for the operator or the driver of the machinery being hit? And this is a safety concern, obviously. And it is probably the biggest challenge also. I know one of your questions is one of the biggest challenges that you have with autonomous machinery is how you make it safe. And it's not just about, okay, can you write better software? Also, how can you design the system surrounding it? So can you make it very unlikely, for example, that a vulnerable road user accidentally walks into the construction quarry? Can you protect the driver in the loading equipment, so that he or she doesn't die if they get hit by a self-driving truck, for example? It's one of the big concerns. Obviously, there are ways that actually become safer. If you think about, for example, waste handling, like having a remote operator or self-driving wheel loader, for example, for waste handling, where you have like toxic materials or very hot materials. Like removing the human from the proximity of the dangerous material is, of course, a huge safety benefit. And also thinking about mining, right now in underground mining, you're working 2 shifts. Like every underground mine in the world is only working 2 shifts currently. Because when you blast, it takes between 6 and 12 hours to ventilate all the toxic fumes that you're going to be releasing when you blast. So essentially you pull the trigger for the dynamite, and everyone walks home, and then the first shift comes back 8 hours later or something like that, and then they can start working on turning big boulders into smaller boulders and hauling it out of the mine, etc. And if you have a remote operated, maybe it's difficult to automate all of these processes. Like, for example, having like explaining to the computer how you turn big boulders into smaller boulders in the correct way. That's a very difficult problem to solve. But you can have remote operated equipment also. So if you think about the underground mine, maybe you have like one drill rig turning big boulders into smaller boulders, and then you have 5 or 10 trucks or haulers running up and down the mine shaft with the material that you are digging out. So in that regard, I mean, of course, if you can automate that, you don't have to care about toxic fumes. I mean, the machine itself doesn't, the computer doesn't care about toxic fumes. So obviously you can operate a third shift if you have remote operated and self-driving equipment. So there's a huge safety benefit, obviously, but also a production benefit in using this kind of equipment, self-driving equipment.
Thank you, Victor. Like now we have touched the safety topic, and like then we have understood like how it operates and all. Like I wanted to know the economic applications, like what economic implications we use generally when it comes to the construction side, and we had to implicate the new tech. It's always given a cost, like it is always be an initial high cost and all those things. So if I ask you, what are the economic implications of adopting autonomous construction vehicles on the field? What is your take on this? What is how you look at the economic aspects of this tech to implement this tech on the field?
That's a very good question. I mean, one thing for certain is that you can have a huge upfront cost for the customer.
Right.
But both with regards to infrastructure, I mean, the equipment on the machine itself. I mean, I'm not going to go into details of what our equipment costs, but you can think of it at least tens of thousands of dollars. For sensors and computers and all of that, not counting like engineering hours, of course. And on top of that, you likely have lots of like infrastructure cost also. You're gonna have to confine the area. You might have to. I mean, if you don't have proper Wi-Fi or telecom communication, you're gonna have to put a telecom tower.
Right.
That's also a big
cost,
customer, of course. Absolutely, it's a huge upfront cost by comparison. Now, with that said, obviously, the customer is going to reap benefits down the road in terms of not having to rely on as many drivers. So if, at least in Europe, a driver can easily cost upwards of $50,000 a year. With like, not just the salary, but also like benefits and insurances, etc., etc. So if you can reduce from like having your 10 drivers to 1 driver, yeah, obviously you're gonna save what's that, $45,000? Oh, sorry, $450,000 a year.
Okay.
So that if you can, I mean, of course, if you're gonna make this economical, you're gonna have to make sure that you can you have a benefit for the customer in the scope of 5 to 10 years at least, because otherwise it's not going to be beneficial for them from a it's not going to be a good investment for them capital wise.
So which means like upfront cost is high, but if you see the long term, that is going to be a profitable venture.
Yeah, so, and also like what was the cost of an accident? If you have an accident, if you're doing like waste handling, for example, and you spill like radioactive waste over one of your workers, depending on where, I mean, if you are in the US, you might go into bankruptcy.
Right.
Yeah, depending on like what kind of legislation you have. So of course, there's that cost to reap down the road also necessarily. Yeah, that might be interesting for a customer.
Yeah. Okay, thank you so much for this costing details. Like being a scheduler guy, I wanted to understand that area also. I understand like if we use automation on the field, then it's definitely gonna the timeline. We can reduce the delays on all those things. So like if I understood in a more deeper manner, like how what do you think that it's this tech gonna help to reduce delays and to help to resource management, like how you see like on that sector to handle resources and all those, this tech gonna benefit over there?
Of course, if implemented correctly, you have a huge benefit to reap with regards to schedulability, as you say. You pretty much already said the same thing. It's quite obvious since you're removing the unknown variable, the person. which can be quite. I mean, okay, they don't need bathroom breaks. You know, they have to go out and take a smoke, etc., etc. All of that, like lunch breaks and so on. Being able to remove that and being able to remove like the uncertainty with regards to that. You can be more certain. Okay, yeah, if we need to produce 650 tons of limestone every hour in this quarry, you are going to have a much more even distribution of that delivery, so you can reduce the maximum capacity of your fleet can be reduced also. Like if you, because when you need to have like all these like lunch breaks and the smoke breaks and bio breaks, etc., you need to have, in order to have an average productivity of 650 tons per hour, let's say, your peak is likely going to have to be like 1,200 tons per hour. So you need to have more hauling equipment available to be able to produce like the sheer amount of mass that you need to be producing. If you have a higher efficiency, like a higher availability on your hauling equipment, trucks and haulers, because they're self-driving and they don't need to have brakes as often, obviously, you can reduce the maximum capacity. So you can, if that means you need to have a maximum capacity of 1,200 tons per hour just before, you can probably reduce that to 800 tons per hour. And still have an average of 650 tons per hour, because you don't have like the problem with like people stopping their truck to go out and have a bio break or have a smoke or whatever. And of course, this is the schedulability here also turns into, I mean, it always pretty much translates into increased profits, increased profitability for a customer, because you don't need to have as much equipment standing around just because you have to hit the maximum target. Of course, I mean, right now with the tech, we are at a situation where availability is about the same as for a person, because you still have issues with like radiocom systems, etc., most of the time, or unfortunately so often that you don't have any practical efficiency increase right now. But with as the tech matures, I mean, for sure, you're going to have a CA increase in productivity here. Yeah. I hope that answered your question. Sorry.
Yeah. I understood. Yeah. Thank you, Victor. I like on with this question we have finished our first category to what problems this tech gonna solve. Now I wanted to move to my second category of questions. Like there, I have few questions on.
Dave, actually, I had one question. So, Victor, as you like mentioned about, like taking breaks or in general the productivity, like this machinery doesn't take breaks, right? It works 24/7, and I mean, so like, does this machineries have any maintenance cost with it? Like, is the maintenance cost also higher? Since the initial cost is higher, but with time, is the maintenance also higher of these machineries?
Not necessarily higher, no. I mean, maintenance on construction machine, the main, even in a self-driving machine, the main maintenance cost is going to be like replacing hydraulic oils, etc., diesel filters, and so on. I mean, that's still the main maintenance cost. The fact that you have LiDARs, radars, GPSs, computers, I mean, they don't break down at nearly the same rate as like normal, like ICE engine components. So that you still have about the same maintenance cost as you would have in a vehicle or machinery driven by a normal person. And obviously you need to schedule that. So I mean, if you have like 500-hour intervals for maintenance or whatever. Normally that's something you can schedule though. I mean, normally if you're, of course, it depends kind of where you are in the world also, I guess, and how skilled your like the guy running the quarry is.
Yeah.
If they follow there's like the scheduled maintenance intervals, it's not going to be a problem. If you have people who have like a more laid back attitude to schedule maintenance, they're going to have issues, because then like shit is going to break down before they repair it, obviously. But in general, yeah, it's the same maintenance cost per individual vehicle as you have on what you have today.
Okay. Thank you, Vibhuti. That's a very interesting question, actually. Okay, Victor. Now we are moving to our second category. Like we wanted to understand like how this technology used in practice. So in this category, I have one question. Can you describe us to what are the typical workflow involved when we implement ASUVs on construction site? I wanted to know what is the workflow. Yeah.
So workflow implementation. Okay. I can only talk about Volvo, and I can only say so much, basically. But essentially, you need to have a customer say contact us and say they're interested in our construction machine, our self-driving construction machine. And normally we'll send that as a kind of sales team to investigate, okay, what's the kind of need that they have right now? Okay, yeah, you're driving 6 big 100-ton trucks. Okay, yeah, we can replace that with 16 smaller self-driving machinery, for example. We can identify, okay, do you have proper telecommunication coverage on your quarry or mine? We only sell electric self-driving. So do they have proper, like, is the grid connection good enough to actually be able to charge these electric haulers also? Going through all of those questions, basically trying to see, okay, is this make a feasibility study? Can we feasibly install our equipment in this quarry or this mine? And then supposing the answer is going to be yes, then yeah, okay, we can proceed and check, okay, what is the, of course, also like checking, okay, what are you actually trying to produce? Like, it's possible to confine the quarry. If we cannot confine the quarry, we cannot really do anything, because we cannot, at least in Europe and US, we cannot sell our solution if we cannot confine the quarry, like from a safety standpoint. But then, of course, if proceeding, of course, we'll send out the commissioning team, making sure that we can install all of the necessary equipment, like make sure we can install telecommunication tower, make sure we can install high power chargers for charging the equipment, make sure we can install like control rooms, which is usually as we ship out like a 40-foot container with all the computers inside of it, etc., etc. And then normally you would have a commissioning process going on for about 1 year at least, and it's also because there's a huge change for the customer, obviously, going from self-driving into going from like people driving their equipment to go for self-driving equipment instead. That's the process, more or less, in a nutshell. It's very long, it's very complicated normally. And we are still like we're not 100% commercialized. You can say that, so it's still a bit experimental also, like seeing. And generally, I mean, the guys in sales, they're gonna go out there and they're gonna say, okay, yeah, this looks all right. I think we have like all the capabilities for doing this. And then you come back to the engineering team saying, no, we cannot actually like achieve this because X, Y, Z. No, we don't, like, I'm gonna make an example up, we cannot have like one-way roads, for example, because the traffic control system is not made to handle like red lights or one-way, like a single lane, two-way roads. There can be such, you understand what I mean? Like, I'm making this example up. We actually have a capability, but we didn't, 5 years ago we did. So if you have a one-way, like a single lane road, for example, and then you have two ways going in, two ways going out. Of course, you will have to have a traffic control system so that will park vehicles and wait for the incoming traffic to pass, and then drive, because otherwise you can have a deadlock on the single lane two-way. Exactly. So usually you have these small caveats in the like traffic control system, for example, that make actually require extra development work from engineering also to make it solvable so you can actually implement the system.
Okay. Moving forward with this, I wanted to know, if you wanted to, like, if we wanted to, install ACVs with the GCs, which they have not used this ACVs before. So we needed to train the people who want to operate this. So is there any type of a training or skill operators required to implement this tech on the field? And if it is there is any typical cost involved in this training or all the stuff?
Training is quite simple, honestly. I mean, you can always just provide like an instruction manual for something, you just go. But generally, I mean, if you want like an efficient training, what you do is you send out, I mean, the commissioning engineers are going to sit down with the supposed people are going to become operators. When the equipment is all there and all set up to go, they will sit down with them for a whole week and just be, okay, yeah, now you are responsible for operating. Okay, make sure you can get machines to start up and start driving in the morning. Make sure you understand how to take them back in the evening. Make sure they understand how to do the maintenance cycles, etc. Make sure they understand like what kind of interventions are expected from the operator. Like I spoke before about, okay, yeah, what if you have an obstacle? What if the machine says if there's an obstacle, I cannot drive anymore, there's an obstacle in front of me? What does the operator need to do in that case? Okay, yeah, they should like, in our case, we have cameras that the operator can view. So you click on a machine, okay, view camera, okay, yeah, then you can see, okay, oh, look, there's a big rock that fell off like the previous truck. Okay, we need to stop and like clear this out. Or there's no obstacle there. It was probably just like a false positive on the perception system's part with regards to like water splashes or dry leaves blowing in the wind, maybe like a goat or something that ran across the road, who knows. Understanding all of those interventions needed also is of course an important part to have efficiency, because I mean, what happens if you don't have unskilled operators? The problem is that they're gonna have like, oh, there's something in front of me, I cannot proceed, and they're gonna be like, proceed in the operator UI, and then they're gonna, the machine is gonna be, okay, I'm told to proceed, so I'm just gonna hit the drive straight into the rock or whatever is in front of me. So it's quite important that you have skilled operators. They don't need to have like driver licenses or something like that, as I said before, but you need to have like people with like some kind of basic computer skills. Luckily, I mean, young guys like 18, 20-year-olds usually very skilled in like basic computer skills. So generally, that's no problem to find. That was of course a problem, of course, because if you take like the 60-year-old guy who's been driving a truck his entire life, he might not have as good computer skills though. So then you might have an issue.
To addition to this only, is there any certification available in the current state, like who's gonna operate autonomous vehicles and all those? Is there any certification?
There's no certification. No.
Okay. Okay. Thank you, Viktor. Like with this question, I have finished with my second category. Do you have any questions, Vibhuti, to ask?
No, you can proceed.
Okay, now we are moving forward to our last category, which is about what is the current state of this technology and the future directions. In this category, I have one question that what is your perspective on the current state of autonomous construction vehicles technology? Like, what do you think? Like, what is like what stage we are now in the industry? Like, are we using it very furiously, and like still there is a need of improvements and all these things? Like, what is your perspective?
Definitely still need for implementations, and I mean it's like widespread dissemination is probably like between 5 to 10 years away. So it's for sure it's coming. There's a huge demand for it. It will come for sure. I mean, we have the technology here. It's just the fact that you need to iron out all the problems that you see right now, and to make sure you can scale it, because obviously it's always like this. Like you can make let's say that it costs $1 billion to make the first product that you ever sell. Just taking the numbers up there. Suppose it costs $1 billion to like be able to develop and ship your first product, basically in this case. Which means essentially in this case like you have 20 self-driving haulers, something like that. To be able to scale this so that you can efficiently make money, so Volvo or I don't know, Doosan or Cat or whoever can actually make money out of it, is probably going to cost $10 billion. So you're going to have the step from like going in to be able to say, okay, yeah, we can actually do this, to being able to scale it up so that your venture capitalists are going to get a return on their profits. That takes probably a tenfold investment. So we are currently at a stage where we spent $1 billion on this. These are not actual numbers. I'm just going with an example. We're currently at a stage where we spent $10 billion and we're able to show that, this actually seems to work. But being able to scale it so, okay, we can reduce the cost of building these self-driving trucks, being able to reduce the cost of commissioning, so that right now it takes us like 1 year to commission a whole site. Ideally, it should take like 1 month if you're going to make it profitable. Being able to scale it so you can get, because there's lots of equipment that you're buying, not really off the shelf, but it's custom made equipment when it comes to like high power chargers. The sensors are still very expensive. Being able to get like volume on all of that equipment you need to put like as infrastructure on the construction site, but also like inside the vehicle itself, obviously. being able to get scale it up so you can actually get a better price on it. All of that is going to take a lot more development and just time, basically, so that you can, as you start developing more and more sites, your suppliers are going to get higher volumes, which are going to push them to reduce their prices, etc. All that takes time, all that takes money. So right now, we are definitely at the verge of being able to say that we are effectively have self-driving construction machinery, but it will take probably another 5 to 10 years before you start seeing like widespread dissemination of the technology.
Okay. Actually, it is like you have answered me. Like my next question was like, how do you think how it will evolve in next 5 to 10 years? So you are like you have mentioned all those things like that.
Cool.
Okay. What is my last question is like, how do you see the roles of ACV changes in the context of sustainability as well as environmental impact? Like, how you see in the like that on those perspectives we implement ACVs?
I mean, there's some things like, of course, self-driving equipment doesn't necessarily idle unnecessarily. I mean, you can schedule like a more fuel efficient if you're. Suppose you are using diesel powered, for example, which is not necessarily always the case, but suppose you are using diesel powered vehicles. Of course, you can. There's a huge interest, and it's actually quite easy to achieve like a higher fuel efficiency when you have self-driving equipment. Like, don't idle the engine, for example, or drive at a lower speed. If, for example, you can plan it so that you're going to hit an intersection in 85 seconds from now. But if you reduce the speed a little bit, you're not going to have to wait at the intersection. You can just pass through the intersection in that case. All of those aspects means basically that you can save fuel, which is, of course, down the road means reduced environmental